All right, everybody, welcome. So, quiz review for our quiz or exam on Friday. So here, what I want us to do is, first, before we do anything, please change this minus 20 to a plus 60, okay? That's very important. What I want you to do is try and do these questions by yourself, and if you feel like you need a little assistance, I'm here to guide you. So if you feel like you're good, go through the problems. So let's look at this. It says, write an equation that defines r of x as a trinomial, right? Think to yourself, what does it mean to be a trinomial? Where r of x is equal to 2x minus 5 times 4 minus x plus 3x squared plus 60. So how would you solve this problem? How do I change this entire thing? How can I express it as a trinomial, right? A trinomial has 3 terms. So here, let's write out the question, 2x minus 5, 4 minus x, and plus 3x squared plus 60. Now here, how do we continue forward? What I want you to do is, here we're going to FOIL it, right? So this is 2x times 4, 2x times minus x, minus 5 times 4, and minus 5 times minus x, right? So 2x times 4 is 8x. 2x times minus x is negative 2x squared. Negative 5 times 4 is negative 20. And negative 5 times negative x is positive 5x. Plus 3x squared plus 60. Okay? Now here, once we get up to this, how do we continue forward? We need to simplify the terms, right? Or combine like terms. So here, try and do it by yourself before you see me do it. But it would be, how would we do it? So we're going to combine the 3x squared and the negative 2x squared. This becomes x squared, right? If we combine this one and this one. What else can we combine? We can combine the 8x and the 5x. So 8x plus 5x is 13x. And what is negative 20 plus 60? That should be 40. Okay? And congratulations, we answered what the question was asking from us, right? We defined r of x, we changed this whole entire thing into a trinomial. So this is my r of x, right? Now let's look at the next problem. It says r of x is equal to 0. So now here we're going to take this r of x and we're going to make it equal to 0. So what is my r of x? It's x squared plus 13x plus 40, and it equals 0. And then how do we calculate the zeros of a polynomial? What are we going to do? If we can, let's factor. And this is in the form ax squared plus bx plus c, where a equals 1. And here, what can we do to factor this? What two numbers when you multiply give me 40, but when I add give me 13? It's 8 and 5. It's positive, right? So it's x plus 8, x plus 5, and that equals 0. And then from here, we can just say x plus 8 equals 0, x plus 5 equals 0. And this should be x equals negative 8, x equals negative 5. And then bam, these are our two zeros, okay? And what I want you to do here is, let's graph it, and we can be very precise, right? If we have negative 8 and negative 5 as the zeros, we know our graph has to hit these 2 points. So let's go to them. This is 1, 2, 3, 4, 5. So I know it hits here. And I know it hits, if this is negative 5, this is 1, 2, 3, this is negative 8. So our graph has to look something like this. And here it is. It'll look something like that. All right? How far down it goes, we'll talk about that in the next lesson. But as long as you have this idea, that's really nice. And if you want, we could just put it into the calculator real quick to see what it should look like. Let's plug it in. X squared plus 13x plus 40, and if we graph it here, oh whoops, the window is very bad. Let me zoom standard, okay, and then bam, this is our graph here, okay. And if we want to maybe calculate the window a little bit better, maybe make your x min 15, negative 15, and make your max 25. Let's see how it looks. That's a nicer picture, right? Okay, so remember how to adjust the window to make your graph look a little nicer, all right? So this part was pretty straightforward. This questions 1, 2, and 3. Let's move on to the next part. Here, let's look at question 4, and let me get another piece of paper. Okay, so here, looking at question 4, it's saying here is our polynomial, and it's asking us find the zeros of p of x. So if I want to find the zeros of my polynomial, I'm going to make this p of x equal to 0, right? Minus 4x minus 3 equals 0. And what I want you to do is use your calculator to find the zeros of this. If you try and factor this, it won't work out. Let's just try, just for fun. If I say factor by grouping, let's see what happens. What is the GCF of this group? It's x squared, so it will be x plus 2. And what's the GCF of this group? It's minus 1, and this will be 4x minus 3. And we have a problem. You see, we don't have the common binomials. So you can't factor this like we did before. We need to put it into the calculator and actually find the zeros. So let's do that together. Here, when we're using the calculator, what's the first thing we're going to do? We're going to hit second memory. We're going to reset the calculator, right? And boom, reset it. Now, when I want to calculate the zeros for this, if you look in your notes, but what's the first move? Let's plug it in. So if I have x to the third plus 2x squared minus 4x minus 3, right? We should have this, and let's hit graph. Okay, and there we go. This is our polynomial. Now we know our graph, the zeros are here, here, and here. Where it hits the x-axis are the zeros. And I say, how do we calculate them? If you just use your cursor and you're moving left and right and you're saying, oh, Mr. G, it looks like negative 2.978, you have to be very careful. We need to be able to be very precise with how to calculate it. So what do? Second trace, we go to 0, okay? And now notice here, you see how I have my blinking cursor? Remember, the left bound is left of the x value. So sometimes, if it looks like this, right, I want my left bound to be here. Okay, so I'm going to hit enter. Now you see I have right bound after I hit the enter. Now I'm going to make the right bound. Now remember, to move the cursor, you can only go left and right. So now I'm going to put it over here, right? And now here, once I hit enter again, and I hit enter again, oh, sorry. Let me move the calculator. Enter again, bam, it gives me the 0. It's, one of my zeros is -3. Okay, what about the next one? Well, let's see, second trace. I go to 0. And now I'm going to move this. And now notice here, my left bound will be above the x-axis because you have to look left of the 0. All right. Before over here, when I said left of the 0, you were under. But now, when you do left of the 0 over here, you're going to be over. So this is my left bound. Then I go to my right bound. Hit enter. Guess. Enter. And then bam. That's my next 0. It is x equals negative 0.618034. Okay. So that's my next 0. And now let's try and find the other 0 over here. I go second trace, I go to 0, and then I move my cursor. And notice this is left of my 0 here will be under. So I hit enter, and then I go enter again for the right bound. I take a guess, and it will be x equals 1.618034. Okay, so these are my 3 zeros. All right, very nice. Okay. Now it says, let's look at the next part of the problem. It says, let q of x equal 2x plus 3. So this is where we need to understand the idea of, it's saying, let p of, what values will have p of x equal q of x? So here, if I have this polynomial x cubed plus 2x squared minus 4x minus 3, it's saying, what values of x will make it equal to 2x plus 3. Like, if I plug in 5 in here, do I get the same thing as if I plugged in 5 in here? So the way we could see which values will occur for that, we need to graph both of these. So let's have let's have y1 equal this original function, and let y2 be our q of x. And what is our q of x? It is 2x plus 3. So if I were to graph this, notice that this q of x right here, the intersection points will be the values where p of x is equal to q of x. So here, how do I find where this graph intersects with this graph? And that's the question that we have. I didn't get to show it to you in class yet, but it'll be just this. If we go to second trace, and let's go to intersect. If I hit, let's say if I hit enter here, now here, let's look at this. It says first curve, right? When I first curve, look at the top left, it says y sub 1. This y sub 1, when I go left and right, notice I am going left and right compared to that first thing that we plugged in. We're going left and right of that polynomial, right? You see here, look at my first y1. We're going left and right on this. If I hit up, notice it changes. Now my cursor is on the line. So here, when I go left and right, I can move left and right on the graph. But if I hit up or down, you're changing which graph you're controlling. So here it says first curve. Let's go to y sub 1. Let's find that intersection point. So here, let's see. Let's pick a point over here, close to it, hit enter. Now look, second curve, notice where am I? I'm at y2, but I'm on the line. So let's pick a point here. See, this is my first guess, this is my second guess, hit enter, and then look what it does. It locks it in, and the intersection of this graph and this line is at -3, x is equal to -3.2730. So it's saying that if I plug in this number into this equation, I'm going to get a value. And if I plug in this number into this equation, I'm also going to get a value. And these values are equal to each other. And they're actually equal to this y value over here. When you plug in this number into both of these functions, you will get that y value. All right? What I want you to do is try and find the other intersection points and graph both of these together. And I want you to be very nice and precise with your graph. Okay, I'll see you in class.